the other hand, is interest that's calculated on the principal plus any previously accumulated interest. So for the first example, let's calculate the future amount, what will be in the account in the future, and the interest that's earned on $100 at 8% for 3 years, if the money is compounded annually. So if it's compounded annually, that means every year, once a year, they're going to calculate the interest and add it on. So I'm going to tackle this in two different ways. The first method is the repeated use of the simple interest formula. So we're going to do this 1 year at a time. So the first year, using the simple interest formula, we started that year with $100. That's our original principal. Interest was earned at 8%, so I'll drop the percent sign and then either divide by 100 or move the decimal point from behind the number 2 places to the left. So I get 0.08. Now it's an annual rate because we're not told otherwise. And since the money is compounded annually, we're going to do this, that means 1 year at a time. So the time is just 1 year. So it's 100 times 0.08 times 1, or $8. So the amount that's in the account at the end of that year would be the principal that we started with plus the interest that was earned. So $100 plus $8, or $108. Now for the second year, again, I'm going to use the simple interest formula and calculate the interest. We're doing it 1 year at a time. But now the principal, what we had in the account at the end of the first year, was $108. The rate is still 8% annual because we're not told otherwise, and we're calculating it annually. That is 1 year at a time. So it's 108 times 0.08 times 1. Or at the end of that second year, $8.64 was earned. So what's in the account now is the $108 that we started that year with, plus $8.64 that was earned. So at the end of the second year, what's in the account is $116.64. Now our third year, we're going to begin that year with $116.64. Again, the interest is earned at a rate of 8% a year. It's an annual rate because we're not told otherwise. And since it's compounded annually, that means every year they're going to calculate the interest and add it on. So using the simple interest formula again, it's at $116.64 times 0.08 times 1. So $9.33 in interest that was earned. So the amount that's in the account was what we started that year with, that $116.64 plus the interest that was earned, $9.33. So it's $125.97. That's the amount that's in the account at the end of 3 years. Now to find out how much interest was earned, I could just add the interest that was earned at the end of each year. So I could add the $8 plus the $8.64 plus the $9.33 to get $25.97. Another method to calculate the compound interest is to use the compound interest formula. So the formula looks like this. So the A in this formula stands for the future amount. What will be in the account at the end of a specified period of time. The P, that's still the principal. That's the original principal, or original amount on deposit. The R, we know, well, that's the rate, annual unless we're told otherwise. T, we know that that's the time, and that the time has to be expressed in the same units as the rate. What's new here is N. N is the number of compounding periods per year. So if the interest is compounded annually, that means once a year, so N is 1. If it's compounded semi-annually, they're going to calculate the interest every 6 months or twice a year. Quarterly, that means 4 times a year, or every 3 months they'll calculate the interest and add it on. Monthly, and daily. If we use the banker's year, then N would be 360. All right, so if we want to find the future amount on $100 at 8% for 3 years, P is 100, the R, that's 0.08, that's 8% as a decimal. That's an annual rate because we're not told otherwise. Going to leave the money in there for 3 years so that the rate and the time are in the same units of time. Now, N, if they're compounded it annually, N is 1. So I'll just substitute it into the formula. So it'll be 100 times 1 plus R, 0.08, divided by N, and it's 1 in this case, close a parenthesis. Now, whatever your exponent key is, it could be an x to the y, a y to the x, it could be a little caret like that. That just tells us an exponent's coming, and in parentheses, I want N times T. T was 3. I'm going to enter that all in one line. I'm not breaking it up, doing parentheses first, then exponent. I'm going to just do it all, let the calculator do the work, all in one line. And what I get is 125.97. The same amount that I got in the previous example. That's what will be in the account at the end of 3 years. So to find the interest earned, I can just take what's now in the account and subtract the original principal. So I can take that 125.97 and subtract the $100 we started with. Over the 3 years, that account earned $25.97. So using the formula, let's calculate the future amount and the interest earned on $3,400 at 6.5% compounded semi-annually for 8 years. So here's the formula. So the P, that's the 3,400. Now for the rate, I need that as a decimal, so drop the percent sign and either divide by 100 or move the decimal point from where it is 2 places to the left. So it's 0.065. It's an annual rate because I'm not told otherwise. I'm going to leave that in the account for 8 years. Since it's an annual rate, my time should be in years. It is. Now, and if it's compounded semi-annually, that means twice a year or every 6 months. I'll calculate the interest and add it on. And it's 2. So I'll just plug it in. So 3,400 times 1 plus R, 0.065 divided by N, so divided by 2, exponent, in parentheses, N times T. Close the parenthesis. I'm going to do that all in one line, and I get the future amount of $5,671.79. So to find the interest that's earned, all I have to do is take what's now in the account and subtract the original principal. So what's now in the account is that $5,671.79 minus the original principal, the $3,400. So the interest that was earned is $2,271.79. Okay, so we want to use the formula to calculate the interest earned on $6,743 at 7.75% interest compounded quarterly for 5 years. So, using the formula, the future amount is the principal times 1 plus R over N, exponent N times T. Okay, so the original principal is at $6,743. Now for the rate, I need to get rid of that fraction first. So 3 divided by 4 is 0.75. So I have 7.75%. To put it in a form so that I can calculate it with it, I'll drop the percent sign and either divide by 100 or move the decimal point 2 places to the left. So I have 0.0775. Now I know this is an annual rate because I'm not told otherwise. And I'm going to leave it in there for 5 years. Since it's an annual rate, I need the time in years. It is. Now N, that's the number of compounding periods per year. So if they're compounding it quarterly, that means 4 times a year. See, every 3 months they calculate the interest and add it on. So if I plug this in, that's 6,743 times 1 plus R, 0.0775, divided by 4, then whatever your exponent key is, I'm using the little caret, N, which is 4, times T, which is 5. Make sure you have all the parentheses in there. So the amount, what's in the account at the end of the 5 years, is $9,897.66. So to find the interest that's earned, we'll take what's in the account now and subtract the original principal. So what's in the account now is at $9,897.66. Subtracting the original principal, that's $6,743. And I see that what's earned was $3,154.66.